Sorry, I forgot to email these to you. Number 6 and 8, right?
Yep.
What's the best type?
String cheese.
Oh man, that's the worst.
I like
Good morning, Brad. Good morning. I heard you had an exciting weekend.
Did I?
Oh, yeah. Mr. Townsend, could you please fill this out from U Alpha Theta? We'll see.
Great minute, bro. Forgot.
Okay, promise. Okay, I understand.
Oh, that wasn't that. I gotta say hi to Steve.
Get thirsty.
Oh, I forgot to fill in my water bottle this morning. Morning.
I'll bring it back there.
Phones.
It's 8:48. Oliver Ben. Did you finish number 9 and 10? What I just asked you, yeah.
Brady.
Matter of fact, I helped you on mine.
Not all.
Yahoo.
Look at it from a different standpoint. Technically, I'm correct.
I can't play all the cameras. She's like, "Clearly nothing to do that way." When you do say that, and I go, wait, it's like a little kid.
So I guess we actually have to finish something.
Morning, Calvin.
Good morning, Braden.
You don't do that. Didn't you do that?
What decision?
That would be so much fun. Isn't it just fun?
Isn't it just?
Hey, they'll let anybody substitute, won't they?
Oh, that was the greatest thing I was saying.
Mr. Frost.
Yeah.
So we
He's in high school.
will-
Shut up. Let's
Yeah,
certain
Did you see what Panda made?
Mhm.
It was pretty fun.
I have one
I like
sister,
it.
Gavin, and this one here. You say you're probably gonna get one.
Oh, I saw this really good pickup line that I can't forget. I can't. There's like
Sixth grade, I was like, I'm gonna call my name.
oh, I saw this really good pickup line that I forgot about.
Okay, there is a handout this morning, so if you didn't think to grab it, you need to go get it, please.
I just made that one up.
From
He's up late.
So Lord of the Rings.
Settle in, please.
Big Bang. It's not the same thing. Because I say words.
Guys, minute of silence, please.
Thank you very much. Will you please stand if you are able I pledge allegiance to the flag of the United States of America and
to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Good job, guys. Okay, so first off, make sure I numbered this one for you. This one should be number 11. So we are going to move on to our third new BC topic today. So I'll remind you real quickly while you get settled in here. The first BC topic was the partial fractions. We practiced that a couple different days. The second BC only topic was the integration by parts and this formula. So you've got a little bit of practice there. And our third one is going to be improper integrals. So we're going to work through this one today. You can see it doesn't have a lot of questions to it. 11 questions plus the notes on the front page. But these questions do take several steps. So, and then if you're not finished with assignment 9 or 10 from last week, then I will ask that you work on that after you finish assignment 11. Okay, so look at this question number 1, and oh, you can't see it. Okay, so if we look at question number 1, before I tell you how to fill in the notes there, what looks different about that where it's not something that you already know how to do?
Yeah, the infinity looks different.
Okay, so to integrate, if part of your integration goes to infinity or to negative infinity, this is what we would refer to as improper integrals. So, luckily, the way that we're going to deal with this is really just connecting other calculus things that you already know. You don't really learning any new calculus other than seeing how to piece a few things together that you already can do for questions like this. Okay, but up here, there's a couple different ways you can set this up. You often need to think about which one is which. So if you're going from some number to infinity, like this, then when we integrate this, it's going to integrate, you're still going to be integrating f of x, dx, but instead of integrating a to infinity, and we don't know how to just plug in infinity like that, we're going to integrate from a, again, a is just a generic number, usually we know that, in question 1 down here it'll be 1, but instead of saying infinity, we're going to put t. And in front of all of this, why I left a little bit of space, is we're going to say at the end, we're going to take the limit as t approaches infinity. So that's kind of our workaround. So we'll still be able to integrate the same old ways. We're still going to evaluate at t and then to a. A is going to be a number, t is not going to be a number. And then the only difference is at the end, you're going to have some t's in your antiderivative, and we're going to do the limit as t goes to infinity. So we're basically just going to plug in infinity for t's and think about how that changes. Now, if it's from negative infinity to b, then of course the difference would be you're going to integrate from, you're going to integrate the same old stuff. You're still integrating f of x dx, but instead of negative infinity to b, we're going to go from t to b, and at the very end of the question, we'll take the limit as t approaches infinity. So, to do these questions, you can see we're going to have to do a limit.
Infinity or minus infinity?
Sorry, negative infinity. Thank you. We're going to have to brush up on taking the limit at the ends of the question. But again, the first part, the integration, should be just one of the things that we already know. I don't think any of these integrate too terribly. But I have another improper integral worksheet I'll probably have you do for practice someday that has some partial fractions and some integration by parts in addition to this. Okay, so what we are trying to do with this question number 1, let's use this as an example here. Remember, integration, a good visual for integration is the area under the curve. So this is wanting to know if you took all this area from 1 to infinity, and you can see this approaches 0, but it actually never reaches 0. So it keeps adding a little bit, a little bit, a little bit, a little bit, a little bit. This integral represents all of this area, even though this one continues on forever, because integration is set up to do an infinite number of rectangles like Riemann sums. So first off, you need to make sure you make a good habit of showing all of your steps here. Like most of our calculus stuff, if you're even if you're good at these, if you're going from step 1 here, and then step 2 is over here, and then step 3 is here, and then you're out of room, and step 4 is over there, it's going to be very hard to keep up with. So we're going to do limit. We're going to just make sure we practice and just make sure that we develop good habits on how to write this out. I'm going to do the limit as t approaches infinity of the integral 1 to t. And instead of calling this 1 over x to the 4th, I know I'm going to integrate this in a minute. So how could we rewrite that?
X to the negative 4.
Okay. And again, honestly, if you remembered how to do limits and you can integrate, you've really seen most of what you need to know about this. It just takes some practice. So the limit, don't be lazy. It's got to calm down for the ride. Until we actually do it, it needs to stay part of our work. Over here, we can integrate. We can raise the power by 1, divide by the new power. Raise the power by 1, divide by the new power. We're going to evaluate it from 1 to t. Okay, again, I know it seems redundant, but you better not be saying equal if you're not writing the limit each time. And if you're not writing the limit each time, you're going to forget about it sometimes. So make a habit out of that. I'm going to simplify this. I'm going to move this down to the denominator. Okay, so the first time I'm going to plug in t. The next time I'm going to plug in 1. And then we're going to subtract those values like we always do with the fundamental theorem of calculus. And before we get our answer now, we just need to try to plug in infinity anywhere there's a t and simplify hopefully down to a numeric value. So if I plug infinity into this, what happens to this fraction?
0.
Okay. There's no t's here, so this ends up being negative times negative 1 over 3, which would be positive 1/3, and 0 plus 1/3 is 1/3. So again, this type of question, there are questions that'll be harder than this one, but on surface level, again, it's just really applying or connecting a couple of different calculus things that we learned in AB. Really, the main highlight here is you can't say infinity, so change it to a value like t and make the limit as t goes to infinity, and then that takes care of that. Okay, another big topic that we're going to have to do a ton of, and it just briefly comes up on this one, but on this one, when we added up all this area and we ended up with an answer of 1/3, 1/3 is a finite number. You can count to 1/3. So if you can get to a finite number, a number that you could count to, given enough time, it is said to converge. So you just keep up adding, and if you add up forever, eventually it reaches 1/3. But if you keep on adding, and it just keeps getting bigger and keeps getting bigger and keeps getting bigger and keeps getting bigger, and it just keeps going to infinity or negative infinity, we say that it diverges. So when we do our series unit, which is the hardest BC specific unit, every single question is practically about converging or diverging.
Can you tell convergence from divergence by the graph itself?
From the graph,
Yeah.
no, but sometimes from the function.
Okay.
And we'll talk about that right down here. Again, you don't need to know too much about converge versus diverge right now. But let's do question 2, and then we can fill in this part. So we're trying to figure out from 1 to infinity. So if I just kept adding this up forever, what does that add up to? That's the visual for what this question represents. So I can't integrate from 1 to infinity, so instead we do 1 to t, and out front to say the limit as t approaches infinity. I'm going to leave this 1 over x because I know how to integrate 1 over x. To integrate 1 over x, that would be the natural log of x. Again, the limit should be the last thing you're doing. It's just along for the ride. Plug in t the first time. Plug in 1 the next time. Subtract those two values. Now, right here, we know what the natural log of 1 is. That is what? 0. Okay, and then there's nothing else I can really do with this. Sometimes you want to simplify this, by the way. You want to like try to condense this before you do the limit, because it'll be hard to see what it goes to otherwise. But we can't really do anything else, so we plug this in. And so as t gets bigger, what does the natural log of t go to? Right, it just keeps getting bigger. And so the answer to that question would be infinity. But because it doesn't, infinity is not a number you could count to, give it enough time, we say that this diverges. It does not converge to a number, it just keeps on getting bigger and bigger and bigger. So if you compare those two graphs in questions 1 and 2, the graphs don't immediately scream at you. Question 1, sure, that's 1/3, but then all of a sudden it looks like you just bumped that function up a little bit and all of a sudden it diverges. So you don't want to guess from the graph, you want to actually work it out. Okay, and then if we compare this to this, these two are the same thing. This is the one that you have to memorize for improper integrals. You'll have to memorize a bunch of these for series and sequences. But if p is greater than 1, we would say it converges. And if it's in this format and p is less than or equal to 1, it would diverge. So what was p in question number 2? So really, once we memorize this particular form, you should know that it diverges right at the beginning, right? If p is less than 1 or equal to 1, it will diverge. If you're integrating from 1 to infinity of 1 over x to the p, which is a common one. Okay, everybody still okay? Okay, now let's move on then. So if you wanted to integrate something like negative infinity to positive infinity, we can also do that as well. And we're going to do what they suggest right here. And we're basically going to split it up at some value. So we're going to split this into two integrals that are both e to the x dx. But instead of going negative infinity to infinity, maybe I'll go negative infinity to 0, and then 0 to infinity. Everybody okay with why those match up? Again, I would always like to phrase this in my head as area. The area from negative infinity to 0 plus the area from 0 to infinity is the same as the area from negative infinity to 0. It's just splitting it up into two parts. Now, like we saw earlier, I can't integrate. I don't want this to say negative infinity. So what I'll do is put a t there and throw out the limit as t approaches infinity out front. And then that's going to take care of that. Negative infinity, thank you. That's obviously something I need to be more careful with. Over here, I don't want this to be infinity, so what should I put?
T, or limit as t approaches.
Well, if you say negative t, that implies that it's related. You don't want to use anything t related, because then it's confusing. Are you talking about this type of t or this type of t? They're two different things. So really you can use any letter you want to, but I think most people do b if you need a second one. So I'll do the limit as b approaches infinity. Okay, so in the end, well, not in the end, we still got a couple steps to go here. To integrate e to the x, it would be e to the x, and we're going to evaluate it from t to 0. Then we're going to add, once again, integrating e to the x would be e to the x, but we're going to evaluate it from 0 to b. And I will color coordinate some of this now. I'm going to still leave the limit alone. The limit's probably your very last step. but plug in.
Negative infinity. That and the previous one as well.
Okay, so I'll plug in 0 the first time, get 1, plug in t the next time, get e to the t, slap a minus sign in between them. Okay, so that area plus this area is the same as that area. So once again, e to the x is e to the x, so I'm going to plug in b the first time, which would give me e to the b. Then plug in 0 the next time, e to the 0 would be 1. Anything to the 0 power is 1, which gives us this. Okay, and then let's try to figure out what's going on with all of this after the limits. So I'm going to try to plug in a negative infinity here. So this is going to give me a 1 minus, what is e to the negative infinity? E to the negative infinity is not infinity.
0.
Good. You can think of exponent rules, move this down. Denominator is unbounded, numerator is bounded, so it goes to 0. So this is really just becomes 1 minus 0 plus, okay, when I plug infinity in for b, a number whose exponent just keeps getting bigger, what does that go to? Okay, so in the end, I've got 1 minus 0 plus a number that keeps growing forever minus 1. So all of that goes to, and does that converge or diverge? Diverge. So, kind of tricky questions you can see, and that they can be kind of long, but again, the integration's the same, the evaluating's the same, limits are the same. It's really just that setup of understanding how to piece those two things together. Okay. Yeah, he came in late.
Wow.
Don't worry, I got him.
Traffic was all. That's bad. Traffic was bad. Come on. Keep telling me like.
Well, you left your alarm clock to go off the same time as last year, right?
Did you really? No.
Well, that's your mistake. Okay, there is one more twist to these questions, so we need to fill in the last notes and look at 2 more examples. This is not necessarily just about integrating from with something to do with infinity or negative infinity. It can also help us with stuff that is undefined. So notice right here, you see how it says we can include a, but we cannot include b? Something about b is undefined, where we can't do that. So what we will do is we will integrate not from a to b, but from a to t, where the limit as t approaches b from the left. Because if you think about this, this is saying the values from a to b. So you wouldn't take b from the right because that's outside the domain. This is describing these values and those values. Okay, and then we can integrate the same way, but because this is b from the left, it will allow us to proceed, whereas if it wasn't there, we would get something that's undefined. Likewise, if we are a is not defined, but b is defined, then visually, that's like saying, here's a, here's b, you can include b, but you can only include numbers bigger than a. So a must be undefined. It's like 1 over x and maybe a is 0. You can't actually plug it in. So same thing. I want to integrate from a to b, but since I can't do a, I'm going to do t. And then out front, I'll do the limit where t is going to approach. What do you think?
A from the right.
How do you know from the right?
Just the little graph you drew.
Right, so we're not including a, so that means that you shouldn't be coming from the left of a, you have to come from the right of a. Just like over here, we had to come from the left. So you don't have to draw these little pictures here, but it might help you with that. Okay, so we got 2 more examples here, and then I'll have you try one on question 5. But again, this does not jump out to me as an improper integral at the very beginning, because 0 and 2 are not infinity or negative infinity. But if we did this and we tried to plug in 0, there's going to be lots of division by 0, which is undefined, and then we get stuck. So which one of these 2 numbers is going to be a problem? 0 is going to be the problem. So we're going to change this to integrating t to 2 instead of 0 to 2. And t is going to be the limit as t approaches 0, and then from the right or from the left?
From the right.
Right. Since this is 2, we're trying to box in. From the right of 0 to 2 is boxed in. If it was from the left of 2, that would be something different. So, okay, and then dx. Now, the integration, again, you need to not try to do this in just 2 or 3 steps. Sometimes they're going to take more, and you're going to be making the question way harder if you don't. But the limit's going to be the same, the evaluating is going to be the same, even the integration is going to be the same. But of course, the difficulty of integration is just going to change based on the question. To do this one, we would have to do u substitution. And obviously, I'm going over this part kind of quickly, just because we've done this before. Could call this u to the negative 1/2. 1/2 du makes the replacement. Okay, what about the bounds? This is t, should this be t? It just depends. If you want to integrate and then plug in the x's back, then yeah, you can leave it t to 2. But remember, just like u substitution, you better change the bounds. When x is 2, u would be 4 plus 8, which would be 12. And when x is t, u would be t squared plus 4t. So, I can't do anything about the integration being easier. Again, I think today, on this worksheet at least, the hardest you should have to do is u substitution. But in theory, the integration could be integration by parts or partial fractions like we've practiced. Okay, so now we can integrate this. We will raise the power by 1. Divide by the new power. Dividing by 1/2 is the same as multiplying by 2. It's going to cancel out this 1/2. And of course the limit's going to be the last thing that goes away. Okay, so the first time we're going to plug in 12, and we're going to get the square root of 12. The next time we're going to plug in this stuff, t squared plus 4t. Throw a minus sign in between those. And now the last thing we need to finally worry about is this limit. If I plug in 0 from the right, so a number that's technically slightly bigger than 0, in for t, everywhere it goes, what does all of this go to? What does t squared plus 4t go to if you plug in 0 for t? Okay, but is that 0 on the right side of 0 or the left side of 0?
Right.
It's on the right side. The reason that's important is because if this is coming from the left side, this is technically negative, and you can't take the square root of a negative number unless you're getting into imaginary numbers. That's why we need to mathematically say it's from the right so that that's not an issue. So this goes to 0. square root of 12 is your answer. And square root of 12 means it is converging. Because you can count the square root of 12.
Can you explain why it matters which side it's coming from again?
Sure. So if we were just talking about, let me simplify this square root function. Here's square root of x. This is square root of something else. But if you make the stuff under the radical 0 from the left, like this is the whole function. So 0 from the left doesn't exist. You can't take the square root of a negative number. But 0 from the right is almost 0, but it's at least it exists because it's coming from the right side. Yep, Oliver.
Wasn't it multiplying by half in the previous step?
It was, and then I had to multiply by 2 when I integrated. Raise the power by 1, divide by the new power. Dividing by half is the same as multiplying by 2. A half times 2 just made it a 1. I verbalized it, I just didn't write it down. Okay, one more example for you guys, and on this one, let's do a little bit more group participation so I can try to figure out what you might need the most help on. Okay, so in question 5, they want us to integrate from -1 to 1. Is there any numbers from -1 to 1 that's going to be a problem for 1 over x? 0. Does everybody see that 0 is going to be an issue? Then we need to split this up into 2. We'll integrate from -1 to 0, plus, then we'll integrate from 0 to 1. Except, splitting it up this way, the reason I'm splitting it up is because I know it's going to be problematic at 0. So instead of saying 0 here, let's say t, and say the limit as t approaches 0 from the right. Or left, I guess you could do either one there. Doesn't really matter. And over here, instead of going 0 to 1, let's do b to 1, where the limit as b approaches 0 from the right also. Or from the left. I guess it wouldn't matter in this question. You're going to get basically the same thing. So again, you can see this looks pretty messy. If you are not as clean as possible, if you make a mistake, you're going to just really struggle to find it. So this
Why would
is,
it not matter which side it's coming from.
well, what does 1 over x look like?
It's going to be going that, right? Yeah.
Like this?
So
So whether you're going from the left and head to negative infinity or go from the right positive infinity, those are basically going to work out the same.
If it did matter, what would you do?
Well, like if it was some function where it was just this, you could not come from the left because the left doesn't exist. You could come from the right because the right exists.
So you have to do from the right on both of them?
For this one, you could do from the right or the left. It doesn't matter.
But in that hypothetical situation.
Oh, in that hypothetical, it'd have to be from the right.
So you would just have the limit that you have on the right. You wouldn't have 2 limits, right? Because you could only approach it.
Oh, well, sure. If this is all I was trying to do, if this was the function I was trying to integrate, I wouldn't need 2 pieces. I could just do it all in one.
why don't we just do it all in one and multiply by 2?
Oh.
You can if you're sure that it's symmetrical.
Okay.
But is 1 over x symmetrical?
All along what axis?
Along with x.
Well, it is along, what is it?
I think it is.
Y equals
I was
negative
going to
x.
say it is.
Yeah.
Or y equals x, yeah.
Oh, yeah.
But look, if you just double this, look, if you do this area and double it, you're going to get 2 times whatever that is, right?
Yes, sir.
But what you really want is all of this. If this is really symmetrical to the origin, don't you see this area is the same amount as this area?
Yes.
So if this is above and this is below, what would those add up to?
0.
And that's not what you really wanted. So that's why you'd want to split it up into 2.
So is this going to all add up to 0?
No. That was the hypothetical. Okay. let's go ahead and finish here.
Then how isn't it 0?
How's it not zero?
We'll come back to that if it comes up again. I think y'all are worried about probably the wrong stuff here. Okay, we're integrating
We're just interested, that's all.
from -1 to t.
Great question.
No, those are good questions. I just think that y'all might be worried about the wrong part right now. That's all. Okay, 1 over x is, of course, integrates as natural log absolute value. Make sure that you're doing the absolute value, please. If you're not in the habit of doing absolute value when you integrate 1 over x, here's a good example of why you need it. Because first time you can plug in t, the next time you can plug in -1. If you don't have those absolute value signs there, you think this is saying the natural log of -1, which doesn't exist. But because of the absolute values, this turns to a +1, and the natural log at +1 does make sense. That's 0. Okay, over here I'm going to plug in 1. Natural log of 1 is, and oops, what was this? T minus 0. Okay. And then I plug in b. I'm going to get the natural log absolute value of b. Actually, this would be absolute value too. Okay. So notice, because of these absolute values, if you were approaching 0 from the left, it would be slightly negative, but then when you take the absolute value of that, it's going to turn positive anyway. So that's why the left and the right ended up not mattering on this question. So if I try to plug in 0 to the right of this, what does that approach? How did you know that? Very good. If you know what the graph of a natural log looks like, well, not infinity, but negative infinity. 0 from the right is approaching negative infinity, minus 0, plus 0, minus. Here's the exact same thing. So the natural log of 0 from the right. So same picture here. This is what the natural log of x looks like. So this is approaching negative infinity. Now, because of these infinities though, I know it looks like these two might cancel out and add to 0. Unfortunately, it doesn't really work like that. We don't know how fast this one's going compared to this one. So since this doesn't come to a numerical answer, we're just going to say that this diverges. Yes, Oliver?
T and b approach the same thing. So then if you combine the limits into natural log t minus 0 plus 0 minus natural log t, which natural log t and natural log t diverge at the same rate, so it's negative 0 plus 0, which is 0.
There we go.
Math.
Yes, you're right.
So you were right.
Oh, 0. Oh.
Now, I'm cheating a little bit. Because I know the answer to this, and I kind of went, I don't know that I thought about it before the question started. So I guess these two are going at the same rate. If you know what 1 over x looks like, and this is where it really helps if you guys remember your parent functions. If I'm trying to integrate from -1 to 1, you get some area below the x-axis, and then you get the same amount of area above the x-axis. If it's the same area, but some's positive and some's negative, what does that add up to?
0.
0, which is what you guys were getting at earlier. I just couldn't think that far ahead, personally. Okay, so these are going to take a little bit more guidance here. So I want you to go ahead and try, go ahead, flip it over, try question 1, and I'm only going to give you about a 60-second head start. And then I'm going to start going over it too, so you can quickly see if you took the wrong approach somewhere. And I will do that for the first couple with you to kind of just help make sure you're heading the right path and not spending 10 minutes on something that's never going to be right because you made a mistake at the beginning. So go ahead and start question 1, And in exactly 60 seconds, I will make sure you started it the same way I did. Okay, make sure that you set it up the same way as me. And I think I have the answers on the website, maybe not yet, but the answer to this question 1 is 1. So go ahead and try to finish that, integrate it, plug in t, plug in 1, subtract those 2, and then try to plug in infinity for t and see that you get 1. If we need to finish it together, we can finish it together. And then start on question 2. So what I'll do here is, again, I just want to provide a little more guidance here at the beginning. So let me give you 2 minutes to try to finish up question 1 and another minute to set up question 2. So 3 minutes from now, I will show you the setup to question 2, and I will offer to work question 1 if you didn't get that answer.
Mr. Townsend?
Yeah.
If you worked it correctly, could you do natural log of absolute value of x squared for your integration? Why not?
Because if I write down what you said, if you write down that, this is not the antiderivative of this, because if I take the derivative of what you said, you would get 1 over x squared, but then because of chain rule, the derivative of the inside multiplies by 2x. So what you're writing is actually the antiderivative for 2 over x, not 1 over x squared. It's the chain rule that messes that up.
Okay.
It has been 3 minutes. So, first off, here's my setup for question 2. Okay, again, I'd like you to try to finish the question on your own, but is everybody okay with the setup on question 2? That's what y'all did?
Yes.
Okay. All right. Now, oh, and the answer to question 2, as you finish it, should be the natural log of 3. So if you don't get the natural log of 3, try to find your mistake first, and then if you can't find your mistake, I will be happy to go over it with you after I think everyone's had time. Everyone should have had time to do question 1. So does anyone need me to work this one out to help you see why the answer to that is 1? I really don't mind, but I don't want to work it if nobody needs to see it. Okay, so let me give you you're going to need a few more minutes on this one. Let me give you 4 minutes, and then I will tell you how I started this question, just in case you try to do something different. But this is an excellent opportunity for you to think about how to approach that.
I'm not there yet. Yeah, let me go away still.
That's true. That's from yesterday. Is it Mayo? What? I don't know if that's safe though.
I thought you said it was.
I mean, I think it's
hours.
totally fine. Valid.
What if I die?
Read it out. I think so.
Because it's, they do both corrections, the natural log, absolute value x plus a from 0 to t plus natural log, absolute value x plus 1 from 0 to t.
Yeah. Just have to make that my contraction.
You ever tried raw eggs?
No.
Really?
That'd be fun though.
They're pretty good for you. It tastes terrible. Yeah. Are they better than cooked eggs?
So let's say it's
approach to because you cook out the enzymes.
natural log of x plus 3 over x plus 1.
Just when you take them.
I've been doing it my whole life.
Make sure.
I don't think that's
Just on their own.
Let's see.
Sheldon.
Yeah,
That
that
would work.
multiply natural log. You take that
Protein.
squared.
That would taste weird. That would taste really weird.
You're saying
Like cheese with that, mixing protein
From
powders.
0 to t. Well, no, once you take all the integrals over it, it's naturally
Maybe.
log.
That'd be a interesting question.
It's natural from zero.
Once you combine it, once it would be
Love.
natural log.
Okay, it's been 4 minutes, so the tip I want to give you, you probably need a little more time to try to get down to this answer. But when you started to integrate this, you realized that I lied to you earlier today. But also, what's the only way to integrate this?
Partial fractions.
Right, you have to do partial fractions. So if you didn't think after 4 minutes of time to try that, if you didn't think to split that up, then that's the thing you need to learn from. So again, that's fine if you need more time for that, I don't mind. But first, take a second and try to set up question 3, please. This would be, I'll let you guys work a little bit more where you need to after this, and I'll step in for questions. Not there yet.
You said it a little bit louder, Bert.
Oh, yeah.
What before?
All right, why don't you help us out, Brendan?
No, the math strip
It's a triangle.
That's fine.
Triangle.
Cool.
Gotta work on your math.
Yeah.
Geometry skills.
Come on, Thompson.
This is yours now. How did you integrate this? From what to what?
1 to t.
No, I'm asking him.
Who?
Mr. Class Clown over here. Brendan.
Brendan. He's
No.
asked Brendan.
I did. That's why I asked Bert.
Wouldn't it be?
You don't know? It's simple.
Natural log versus natural log.
Is there going to be a problem plugging in 1 or 0 into something like this?
Problem plugging in 0.
What's the problem with plugging in 0?
Because the bottoms can just be 0.
Right, and dividing by 0 gives us undefined.
Undefined.
So instead of doing 0 to 1, you could do
So you did 1.
t to 1, where t comes from,
Well, it's gonna come from the limit.
okay, the limit as t approaches,
Infinity from the right. No.
I'm only interested 0 to 1.
It approaches 0 from the right.
Okay, but good, how do you know from the right?
Because we're going from 0 to 1. This on the left has
Okay.
absolutely no bearing on this.
That's fine, that's a good way to think of that. We want 0 to 1, we're coming from the right side. But also, coming from the left side would give you the square root of something negative, which doesn't make sense. Okay, if you did not set your number 3 up that way, then jot that down out to the side. The correction, and then keep going. So I'm going to take a minute here, and I'm going to put this on our website, the class website, with all the answers. I believe it should have work with it as well, so that way you can start working a little bit more at the pace you should be at and not waiting on me.
So for some reason I just didn't take into account I wrote down plus 1. That's zero. I just didn't know where it was.
Natural logs. Two natural logs.
I remember being like, not down to like my bag.
Super long. You don't remember that?
I also just don't remember.
You got a haircut over the summer. Did you go see the live album?
Yes.
People were seeing they had a long hair.
Like, that's kind of weird.
Yeah, but I feel like it wasn't that long.
No, it was super. It was like
This
long,
is-
greasy.
I rediscovered a man's choice song that I love.
No, I didn't. No, I didn't.
Yeah, you do.
Am I supposed to do the other ones now?
Mr. Braden Leslie. How do I add X plus 1
This is tested for elements.
Oh my goodness, I did that wrong.
No?
Tell him.
You know, Mr. Townsend, calculus is really testing my limits.
Braden, get busy. I'm gonna make this due at the end of the period if you're not working.
At the end of the period, I'm getting busy right now.
Okay, I've been waiting for you to.
Oh, yeah.
What would have been your final last one? Say what? Because you said that like the first 4 subjects is all you did last year.
First semester final was
It is
like,
fun.
final was like 4.
Oh, you said
God, you're right, yeah, you're right. 9 and we got the
That's what it is.
We did do a lot. But final, or last year, I did the second semester, I had the semester final. It's what? U to the negative 1 over 2.
Should be 0 plus 1. Should be 0 plus 1, not 0. So I don't know how to integrate X plus 1. You don't need it for the second. It's a good U. Okay, so, okay, so when we cover all this research.
I am special grade.
Why do you have X plus 1?
It's good you got thumb on what?
Why is it U plus 1?
Yeah.
You tell me.
I agree with that.
Because you didn't turn into the DU. The DU is the 2x plus 2. Uh-huh. And to get the x plus 1, you have to divide by 1/2. So you just divide by plus 1. This is for DU. So
You're the negative 1.
Okay, I do have the solutions on the class website now if you want to start checking as you go along.
That's fine. Got A equals negative.
And I will come around and
Sorry.
As t approaches 0, it doesn't
help out.
left.
This is
What's your?
Let's-
It's easier to go read.
What? I'll let you know.
Make sure you check your answers at the end. That should be square root of 3.
It's right. Thank you. Is this one right? I got it. I'll skip the couple of steps.
Sure, that's right.
Okay.
That's up there, Just like.
No, I was working with Blake.
That's pretty silly.
What happened? True statement.
Yeah, bro.
Let me stand up. That's a pass mine. Just got one more stand up.
Something I can help with yet.
Yeah, number 4. I forgot how to say picture. It's got bricks.
You have to do integration by parts. Is this your integration? I forgot those were on this question.
He's 3 times.
Well, since it's 1 over
For what? Square root 3. For number 4,
That should
you
just be
do
square root
partial.
Final answer to that should be
But usually when the UV
Good, okay.
the integration
For number 3? I got square root.
pretty sure that's what you have.
That's what
I remember to use UV
Okay, I do want to take a minute because I know most of you guys have had time to try question 2, and at this point you realize whether you finished it or if you started getting stuck somewhere. So if you worked it and you got natural log of 3, then you're probably fine. I think it would be pretty hard to accidentally get natural log of 3 as an answer. But if you did not get that, I'm going to go ahead and go over it and record it real quick, and because that's the very end of this question simplifies in a way I think you may not think about. Okay, so for question 2, obviously changing it from integrating to 0 to infinity to the limit as t approaches infinity of integrating 0 to t is kind of our topic today. But to integrate this one, again, you need to recognize the only way to do this is with partial fractions. So you have to take a minute to solve for what a and b would be. It's a little bit bigger. So when x is -1, it looks like b should be 1. And when x is -3, if you plug in -3 for x, you get 2 equals -2a. So you get a is -1. Everybody get that for a and b? Okay. And so then you can say, all right, I want to take the limit of all of this mess where I've got a over x plus 3 plus b over x plus 1, all of that dx. Okay, and then these two should now integrate nicely, which is why the whole partial fractions trick works out so nice. So in the end, I need to evaluate from 0 to t. This would integrate as negative natural log absolute value of x plus 3. This is going to integrate as natural log absolute value of x plus 1. Now here's where I hope that you started to get a little worried, because you could plug t into both of these, but then when you plug infinity into those, you've got parts that keep going to infinity. So instead, let me recommend this. I think it'll make it a lot easier for you to see. First off, what if I just switch these two terms? So the -1 is second. I think it's going to help you see why I'm doing what I'm doing. Okay. I'm going to just keep going down. Isn't there a way to take the natural log of something minus the natural log of something else? Isn't there a way to combine all of that? Right, so sometimes at the end here you're going to want to condense. So you can condense it into a single natural log of x plus 1 over x plus 3. Now when you plug in the t, and then plug in the 0, it's going to look something like this. Okay, everybody still okay with that? I'm going to do something different with this. Okay, the reason why I suggested this is right here. Now that I want to do this limit, if you condense these into 1, you can think of this like a horizontal asymptote. This has degree 1, this has degree 1. So as t goes to infinity, what does this fraction go to?
1/3.
Not 1/3,
Just 1.
just 1. These two are growing at the same rate. The plus 1 plus 3 does next to nothing. So you would do leading coefficient over leading coefficient. So when you plug in infinity for t, this goes to 1, so this really just goes to the natural log of 1, which is 0. And it's fine if you stop there. I guess I took slightly different steps here, so I could work this a little bit further. Since this is dividing, I could split this up into subtracting. Natural log of 1 is 0. Distribute the negative, and you could end up with natural log of 3 also. So, if you struggled with that question, that's fine, because again, this is on the harder end here, but you've got to recognize where you got stuck. If you didn't realize that partial fractions were needed, then that's got to be moved to the top of your list of things to worry about. There's no other way to integrate that besides partial fractions. If at the end you had a bunch of natural log of infinities and negative infinities and you're not sure how it all should work out, consider next time trying to condense those, because then it does simplify a little bit better. Okay, was there anything else about question 2 while it's up here? Any of those steps that I went over too fast that you want to hear again? Okay. Has everybody had time to try question 3 or not? Has anyone not had time to try question 3? Either finish or got stuck?
Just me. Just me.
Okay, I will tell you the answer to, you should go to the website to see all the answers, but the answer to 3 should be the square root of 3. So, if you think you're done with that one, but you did not come up with square root of 3, jot that out to the side and then try to find your mistake. Okay, and I'll let you guys work a little bit more before I offer to help again.
Yeah. I think what you're saying is the integral of negative x. Sorry, integral of negative. The integral negative e to the negative x would be e to the negative x.
Yeah.
Okay.
Yeah, but on this it says it's negative.
Am I good or not?
Yes.
So on the key, it's when you integrate negative e to the negative x, isn't it e to the negative x?
If you integrate what?
Negative e to the negative x.
Oh, you want to integrate that?
Wouldn't it be e to the negative x?
Yes.
On the key, it says it's negative.
Which question are you looking at?
4.
Okay, but you're not doing the antiderivative of e to the negative x. You're doing the antiderivative of x times e to the negative x.
When you do integration by parts, you have
Oh, okay, good. So you realize you had to do integration by parts. Okay, I'm with you there.
Side yard to
Okay, is that what you got after you integrated?
So we find A and B.
You have a plus there. So, I think because it's minus minus. And then when you integrate, it creates another minus.
I don't
See what I'm saying?
is it UV
UV minus integrate C.
I thought it was plus.
Regular.
Yeah. Okay, so that's gonna change that one side, which I think you're not parts right.
That regression.
Like that.
Okay.
As I'm going through this, it's helpful.
Alright.
Because
It's UV minus.
like, what do I do from here? That's
I thought it was plus.
Okay. I don't know if we can,
I just like didn't combine it with this. Does it work?
Wednesday or Monday?
I think because these are exactly,
What's the,
like that you talk about true values to get extremely big.
Literally.
This plus 3 are basically the same, and then natural life infinity and
That's
natural
what
life infinity are basically the
yeah,
same.
even though
That's why
they're-
those are canceling out, when you talk about really big numbers. Because it could be that this one goes to infinity and this goes to negative infinity.
Or
So
even up here,
this goes to
and then it
infinity way
would be
faster.
this would be positive, and this would be negative. There's no point having this be positive.
That's why I would try to condense these to like this, then you can see this is just 1 to 1, which makes it work. I can explain all of it to you, I can help you where you're stuck. This is the UV formula.
Mr. Townsend? Could you explain the inversion by parts?
Okay, so integration by parts, when you're integrating something times something. So this is the one you need the formula for. You gotta pick U and a B prime. U needs to be something that integrates nicely. B prime needs to be the rest, and it needs to be something that integrates nicely.
They both need to integrate nicely?
I'm sorry, the U needs to be derivative nicely.
And X would just go to
B
1.
prime, and B prime needs to be something that integrates.
How do you integrate E to the negative X?
Negative E to the negative X.
And what does that mean? So. How's that?
Well, you gotta plug it in the whole formula.
Yeah, I know, I'm just so I can look at that visualize.
So it's-
visualize
Okay,
that either.
well,
When you sign it,
what
you
can you take the
have
derivative
two
of to get
parts.
E to something?
It's U and V prime.
Natural log of-
Integrate V prime.
Natural log is 1 over X.
So you.
This is
Yeah.
What's the derivative of E to the X?
E to the X.
Okay. So the derivative of E to something, is E to the something, so go ahead and put E
It's not
to
like
the
you
negative
were,
X.
you had V and then you had V.
But, and then check, because I'm skipping U substitution. U substitution is the same thing. If I take the derivative of this, I get an E to the negative X like I wanted. But then because of chain rule, it's gonna multiply by a -1, and there's not a -1 there. So you gotta put a negative to balance out the negative. Now I can take the derivative of that and get to that.
Okay.
You find what tangent.
What gets rid of the negative, whatever we take the derivative of multiplying by the negative from the power.
Which direction are you heading?
So, okay, so taking the derivative of the negative e to the negative x to get to that.
Right?
That negative multiplies by that negative.
Gives you a positive. Good.
Well, the tangent graph is the one.
Thank you.
Yeah. Yeah.
So.
But the key says it's higher too. On question 4, you're gonna have to do integration by parts. you might look at your formula. That's the UV minus integrate B prime, or B U prime. That should be in your binder. One more time. I don't think it is.
This is part of
Okay, well, it's not, it's inverse tangent.
Yeah.
Okay, so inverse means it just means what angle has a tangent that goes to a thing. Remember what tangent graph looked like?
Yeah.
E over 2 or 2 over 8? Like 2 over 8.
Inverse tangent. So the tangent looks like.
So this looks to the okay.
You're probably thinking tangent and not inverse. Yeah. So angle that's approaching infinity is going to be pi over 2.
Okay, I see. Thank you. I didn't even play it.
Really, the two hardest things about these questions should be keeping your work nice and neat so that you don't lose a negative sign or something, and the integration. The integration can be tough too. Whether it's partial fractions, integration by part, U substitution. Honestly, that should probably be the part you feel like you need the most help with.
So since it does actually make it infinity, what on the graph? It's going up too. So at negative it's going to be negative pi over 2. So the other thing is oh no, on it's still pi over 2.
Okay, it's been a while since I helped out on the board, so what is the first one that's giving y'all problems? Question 3, question 4. On question 3, did everybody get square root of 3? Does anybody want me to go over question 3? I'm assuming this means that you did it and you're okay with it. Okay. What about question 4? Has anyone tried that one and know you need help with that one? Okay. What about number 5? Has anybody tried question 5 and realized you need help with question 5? Yeah.
So why is this inverse tangent of infinity equal to pi over 2?
Well, inverse tangent of infinity, this is saying what angle has a tangent value of infinity? Yes. So, do you know what tangent graphs look like?
Yes.
This is negative pi over 2, this is positive pi over 2. So what angle approaches infinity.
Pi over 2.
There you go.
So then negative infinity is negative pi over 2?
Sure. Yes.
Yes.
Okay, does anyone want to see that number 5 worked out? Again, don't ask if you haven't tried it yet. You've got to figure out what kind of roadblocks you're going to have. If I just do it and you haven't tried it, then it seems easier than it really is. Okay, I'll offer one more. Anybody on question 6? Anybody try question 6 and not get that it diverges? Okay. Seems like y'all are okay for right now, so let me let you work again.
You have infinity over each of the infinity. Minus 1 over each of the infinity, so both of those are just 0. Then you have negative times negative 1 times 0. I have one more work to do. Ask Tommy.
Yeah, Tommy knows.
Timmy's doing it all right.
Most
Doing it right,
nice,
but
that's
Timmy's
it.
on question.
Question 2?
4.
Brendan, what question are you on?
3.
That's Brendan.
Because it's unity infinity. The bottom is approaching 0 faster than the top is. The bottom is basically infinity over 0, which is approaching 0. That's wrong.
Negative,
We don't care. It's still 0. I want to go back now. The next one's even easier, but that was. So what would you say is? The bottom is infinity. Since the exponent is infinity, the exponent is exponentially greater than the top's exponent. And whenever the bottom's exponent is higher than the top's exponent, it's approaching 0. Well, that's what the mistake was. Right. I want to get back now. Brendan, you don't want to get back. It's the one like deciding whether it's on it. I have my own work to do. Okay. So. Because that doesn't it's negative over
You may also note that I pushed this back one day,
Yes.
the integration quiz. I figure we need to practice these in proper intervals more than one day, so thank you.
Thank you. Thank you.
Because this is basically 0.
So we're going to practice this again more on Friday, but it's not going to be any easier on Friday if y'all don't get help on this wherever you're getting stuck. So please keep asking.
I have my own stuff to do. Yes, good for me.
I'm glad that everyone's so stupid, so this doesn't happen to me.
Hey guys, I've got plenty of seats over here if y'all are going to flirt with each other every class.
Blake stole my paper.
How's Terry doing?
Doing good. Yeah.
Yeah, finally. Yeah. I'm just gonna put my earplugs in. That'll fix it.
You got fired over
Plugs, earplugs.
Earplugs.
You carry around earplugs?
I play the drums, don't I?
Are your earplugs allowed in class?
Earplugs?
Plugs, like the, yeah.
Yeah, why not?
Okay. Oh,
I have some of them.
nice.
Really?
Yeah.
On you?
Yeah.
Play the dog whistle.
Why?
Why?
Why do you carry earplugs?
Well, I don't carry them. I just leave them over here. See? I got my own ear.
Nice.
I'll try to pair my pockets.
See how much more peaceful this is?
I mean, I can't really tell.
If I put mine in, I start yelling. Because I can't hear my. It's like when you're playing loud music and when you try talking to somebody and you're
I don't think you
talking
can
loud.
hear
Alright, I'm
you.
getting distracted.
You're talking to a wall right now.
I wasn't talking to anyone. It's just staring.
Wait, nobody in class is almost
These
over.
3 people
That's
out here started
crazy.
laughing at me, so I have to explain myself.
We would have 6 minutes left to class, and I've done 4
Did we?
problems.
See, Blake stole my paper, so I only got to do 3 of them.
I'm on number 7. What you on my
It
level?
really is.
What? What did you just say, Brandon?
What?
No, before you just.
So as members, you know what, I'm just You didn't ask me that. You explain this problem to me. You told me this.
Alright, we are down to about 5 minutes, so let's find a good and fair stopping place. I'm gonna say, I think through question 6. If you did not finish through question 6, you need to do that much for homework. You're encouraged to do more than that, especially if you think these are extremely hard. But I will give you some more class time on Friday for that. But since we're down to a couple minutes here, it's time for another puzzle. Yes.
Where are we supposed to turn in our?
You don't need to yet.
Okay, good for you.
I want to make sure I give you more class time. And it didn't happen today. Alright, if you'd like another puzzle, here you go.
4 bottles of milk, 1 bottle of spices. So you have 1 rat? Is that the problem? You have 1 rat? Or you have multiple rats that you need?
You could
How many
see
rats do you
wait,
have?
Oh, okay. You're out. Oh, shoot.
How many rats?
You drink 2 bottles and you feed the rat 2 bottles, whichever one dies. the
How
two
many
others.
rats?
I don't know. I don't know this puzzle. Yeah.
Do you
Because if you get multiple rats, then I know how to do it. And I have to
do
make
you
a little
give the
bubble.
rat different milk every hour and then set a timer
I don't know.
to figure out which one's poison?
There you go.
And then you drink all the other ones.
Dang
That's
it.
it.
I was just gonna say it's the lame puzzle. Feed it 2, drink the other.
So that's it, that's right.
Yeah, that makes sense.
So you're saying give them bottle 1 at the start, bottle 2 after an hour, bottle 3 after an hour more,
Yeah.
bottle 4 after an
That's
hour
4
more.
hours.
And then
By
base,
14 hours.
if it really kills them exactly after 10 hours, you know which one is poisonous.
Yeah.
That makes sense.
This one.
Really, you only
I was gonna say.
Okay, but wait. There's
There's
something wrong. There's something wrong with your thought
It never
process.
said you have to live.
You have to drink 3 bottles of milk.
Yeah, but
Yeah, you
there's
just
one
drink the
poison.
3 that
Yeah.
wasn't poison.
Well, whatever kills them after 10 hours.
But you took some of it out
Well, yeah.
to let him test it. So you didn't drink 3 full bottles of milk.
It doesn't
Just
say-
drink from 3 bottles.
You just have
Stop
to
being
drink
semantic.
You don't have representation of each sample.
It takes.
It doesn't say you have to live either.
What strategy would ensure you drink 3 bottles of milk?
Let's be honest.
Not 3 bottles minus 3 sips.
I know I'm a really good gambler.
I'll take this one.
Just feed the milk. Not me, right? Not me, right?
I know, you said okay.
There is small rats in my
Yeah.